Hi students, it's Mr. Henrik. Now we are going to learn Stewart's theorem. Stewart's theorem is a prerequisite knowledge if you want to learn deeply geometry. As usual, before I begin this lesson, don't forget to click like and subscribe for this video. And if you want to ask me something after this lesson, you may send me your message to my email. Okay, I will begin with this case. If you want to find BD, it's very simple. You just find the area of this triangle. You know that area of this triangle, you may find through this formula, half times BC times AB. Or you may find through this formula, a half times AC BD. How to find BD? BD, you may find through this formula 2 times A over AC. Very simple. Very simple because BD perpendicularly to AC or AC perpendicular to BD and AB perpendicular to BC. Right, but how about if BD position in this triangle like this? Yeah. To find BD, we cannot apply this rule. Yeah. We cannot apply this rule. We may use Stewart's theorem to find BD. Okay, let's move to the next slide for Stewart theorem. I'm going to prove Stewart theorem by the law of cosine. Look at this triangle. AB equals C, AD equals T, AC equals B, DC equals phi, and BD equals U. According to Stewart theorem, that B squared, according to cosine theorem, cosine theorem, B squared equals phi squared plus T squared minus 2 phi T cosine theta. This angle. Okay, this first equation. And according to cosine rule, C squared, this C squared equal U squared plus T squared equal 2 U times T cos theta. Okay. Oh, I mean plus here. Yeah. Yeah. So according to cosine rule, that B squared equal phi squared times phi squared plus T squared minus 2 phi T cos theta, while C squared equal U squared plus T squared plus 2 ut cos theta. Now we are going to eliminate 2 phi t cos theta and 2 ut cos theta. It means we will multiply the first equations by u and the second equations by phi, multiply by u and phi, and it becomes ub squared equal u phi squared plus ut squared minus 2 u phi t cos theta. The second equation becomes phi c squared equal phi u squared plus phi t squared minus, or plus I mean, plus 2 u phi t cos theta. Okay. Add, eliminate. Okay. If add, it becomes ub squared plus phi c squared equal u phi squared plus phi u squared plus ut squared plus phi t squared. Okay. And we may simplify, becomes u plus phi times, okay, times u phi, okay, times u phi plus, of course, t squared times u plus phi. Okay, and of course this ub squared plus phi c squared. Okay, and I'm going to move here to this space. So it means ub squared plus phi c squared equal u phi times u phi times u plus phi. It means u plus phi, it means this one, yeah, bc. Okay, u plus c equal bc, and then t squared times bc. Okay, so I will writing u phi times bc, just change position, t squared bc equal like this. Okay, just change position, and you know that u phi, u equal bd times phi equal dc, bc, of course, plus t ad squared and times BC equal UBD times BAC squared. Okay, plus phi equal DC times C squared AB squared. Okay, so this is the Stewart theorem we are going to use in this lesson. You may rearrange this rule. You may rearrange these equations become the simplify according to what kind of several problems you're going to find the solution. Okay, now let's discuss this first problem. On triangle ABC, F at the midpoint of AB, if AC equals 6 centimeters, BC equals 8 centimeters, AB equals 12 centimeters, find CF. Okay, and if you construct a triangle like this, A here, ABC, and CF. Okay, we're going to find CF. Okay, in this case, AC equals 6, BC 8, okay, and AB 12, and F at midpoint, it means AF 6, and FB 6 as well. Okay, now, according to the Stewart theorem, that AF times FB times AB, okay, AB is AF plus FB, plus CF squared, okay, CF squared, okay, times AB, AB is AF plus FB. Yeah, I'm going to write down there. If I write down like this, AF, okay, AF times FB times AB, according to the Stewart theorem, of course, plus CF squared plus CF times AB equal AC squared times FB plus BC squared times AF. Okay. Substitute this line segment with the number AF 6, FB 6, AB 12, CF not yet, AB 12, AC 6, FB 6, BC squared 8 squared, and AF6. Okay. And next, it becomes, we may divide it by 6 to simplify. Divided by 6 comes 1, and comes 2. Becomes 72 plus 2 CF equal 36 plus 64. Okay. So 2 CF equal 36 plus 64, 100. 100 minus 72. So CF squared equal 28 divided by 2. So CF squared equal 14, and CF squared 14. And the unit is centimeters. Okay. So CF equal square root 14 centimeters. Okay, I think very simple. Next problem on triangle AB, triangle ABC. AB is 4 centimeters, BC is 8 centimeters, and AC 6 centimeters. D on BC, D on line segment BC, and BD equal to centimeters. E on line segment AC, okay, and AE equal 4 centimeters. Find DE. If we sketch these problems, it becomes like this. Okay. To find DE, of course, we need to find AD first. Okay, how to find AD? According to Stewart theorem, AD squared times BC plus BD times DC times BC equal AC squared BD AC squared times BD plus oh yeah, AB squared DC, yeah. AD how much? Not yet. Need to find AD. AD squared times BC how much? BC 8, okay. BD, BD 2 times DC 6, BC 8, AC 6, BD 2, AB 4. So it becomes 4 squared DC times 6. So AD, 8AD, I mean, 8AD squared. Two times 6 times 8, 96, I mean. 96 equal 72 plus 96. Okay, so 8AD equal 72 because 96 minus 96, and AD equal 72 divided by 8, 9, square root 9. So AD equal 3. Okay. Now we're going to find DE. Okay. I'm going to use this space. According to Stewart formula or Stewart theorem, that DE, look this line segment DE, DE times AC, DE squared here, DE squared times AC plus AE. AE times AE times EC, AE times EC, okay, and AC, yeah, times AC, correct, equal DC squared, okay, DC squared times AE times AE, yeah, correct, plus AD squared times EC. Okay. D, how much? We're going to find DE. Not yet. So DE squared times AC, how much? AC 6. AE, how much? 4. EC 2. AC 6. DC 6. AE 4. AD, this one 3. EC 2. Okay. So 6 DE. 6 DE squared plus, yeah, 48. Equal 24 plus 6. Oh, 3 square here. 3 square, and DC is, okay, it means 36 times 4. Wait. 36 times 4 equal 36 times 4, 36, 144. and 9 times 2, 18. Okay, so 6DE squared equal 144 plus 18 minus 46 minus 48, I mean this number. Okay, and it becomes 6DE to 61 minus 48, 162 minus 48, and it becomes it's square here, 4, 1, 1. So it means DE square equal 114 divided by 6. Okay. So DE square equal 6 times 1 and 4. 154, 9. Okay, so DE square equal 19, and DE equal square root 19 centimeters a unit. So this is DE, the length of line segment DE. Okay, let's move to the next problem. On triangle ABC, AB equal 8 centimeters, BC equal 7 centimeters, AC equal 6 centimeters. D on extension line segment AB. On extension line segment AB such that BD equal half AD. Find CD. Okay. If you sketch this triangle like this, okay, look at AB equal 8 centimeters, and BD is a half of AB. Okay, so BD equal AB plus BD. BD equal AD minus AB. We're gonna find CD. This. Okay, according to Stewart theorem, that we need to find BD first. If we already find BD, we may calculate CD. Okay. So it means 2BD equal AB plus BD. And AB equal 8. Okay. 8 plus BD. Because we have no information of BD. If this 1 BD moves to the left side, it becomes 2 BD minus 1 BD. Equal 8 centimeters. So BD equal 8. This is BD, not BP. BD, yeah, 8 centimeters. Okay, now we need to apply Stewart theorem. AB times BD times AD, okay, plus BC squared times BC, yeah, times AD equal AC squared times BD plus DC plus, yeah, DC squared or CD squared times AB. Okay. We need to find this one, DC squared. AB, how much? AB 8. BD, BD equal this one, 8 as well. AD 16, because 8 plus 8. BC 7 squared. AD 16. AC equal 6. BD 8. DC squared. AB equal 8. So if we divided, I think, divided by 8. Divided by 8, it becomes 1, becomes 2, becomes 1, 1 here. Okay, that means 128. 8 times 16, yeah, correct, 128 plus 49. 49 times 2, 98 is 36. 36 plus DC squared. Okay, so it means DC squared equal 128 plus 98, 6, 2, yeah, 226 minus 36. This one. Okay, and DC equals square root 226 minus 36, 190. So DC equal square root 190, of course, centimeters, the unit. Yeah, this one. So DC or CD equals square root 190, square root 190 centimeters. For your exercise, this problem, and you may send your solution to my email, or if you have any questions regarding this explanation, you may email me through my email, this one, henrik.academy21@gmail.com. Students, thank you for joining with me in this lesson. And don't forget, email me and give your advice or suggestion below of this video. Okay, thank you. See you.